XRF, SAM, what is their principle and advantage and how we can use them for archaeometallurgical research. And then I will give some examples from South Asia, mainly India and Bangladesh. And then we'll talk from my experience, some challenges and prospect of this kind of scientific research. So we can start. So what is archaeometallurgy? Actually, archaeometallurgy is a sub-discipline of archaeology. We can define archaeology is a scientific approach towards the past metallurgy or metal technology. It's a synthesis of two disciplines: archaeology, which concern mainly with the knowledge of ancient culture, and also metallurgy, which is a science of metal technology. So both archaeology and metallurgy mixed with archaeometallurgy comes from this.
Excuse me, Mr. Bikun. Excuse me, Mr. Bikun. May you make full screen your presentation, please? Make it full screen. You click below.
Okay. Okay. But
this one under the right side below, you see the full screen. Okay. Yes. Yeah. Okay. It's already good. Thank you.
Okay, thank you. Thank you. It's okay now? It's okay?
Okay.
Okay.
Yes. Start it.
Okay. So we can easily see archaeometallurgy is nothing but a synthesis of two disciplines, mainly archaeology and metallurgy. And in general, archaeometallurgy is deal with the metal artifact, mainly concerned with the ancient past metallurgy. Why archaeometallurgy deals with metal? Why metal is important? Actually, metal is very important for humankind. When man or human introduce the metal, when human culture is known to metal, the human culture is, changed in a very diversified way, because this metal has a very characteristic feature, like all metal are malleable. All metal are malleable and ductile. So metal can be forged hammers, and thus it can be formed in a various shape. And also metals is very sonorous, so it can also used to make a bell, and metal has a very metallic structure. So in ancient culture, metal was used for making mirrors and some religious objects for this luxury. And most importantly, metal has high melting point. Usually in room temperature, metal is solid, but in a certain temperature, human can melt it and mix with different metal, make alloy, and also this due to the melting point, it allows us to use cast to make a different object in a like sculptures, coin, and other objects. So for these qualities, metal is very important, and metal change the human culture in various ways. So archaeometallurgy, through the archaeometallurgical research, we can seek the answer of various questions, like what type of metal was produced in the past, what kind of object were manufactured, which mines were operated, or different kind of question like how metal was, different technology was introduced using metal, or what type of effect was social organization, economical or environmental impact. So like as a metal is a very specific category of archaeological records. So to study the metal, we need in archaeometallical discipline, we need a very scientific methods. I will share three basic techniques that are usually used for archaeometallurgical research. These are X-ray fluorescence, XRF, and X-ray diffraction, XRD, and scanning electron microscope, or SEM. Mainly XRF is used to know the chemical composition of metal object, and XRD for mineralogical characterization, and also to know the microstructure. Usually we archaeometallurgists use SAM. Okay, let's see some principle of these three techniques in a brief, like X-ray. The principle of X-ray is very easy. It's based on the interaction between high energy X-ray and the sample. Usually in X-ray, a sample is excited with a primary X-ray radiation, and when, like if you see this, when the high energy X-ray is penetrated sample, then an electron from the inner cell was knocked down, and in response, a electron from outer cell is coming to the fill of the void, and then they created an extra new fluorescence, and this fluorescence is very much unique to each element. So the energy or the intensity, by counting the energy and intensity of this new emitted fluorescence, we can know what type of metal element is present in our sample and how we can quantify as well. So this X-ray is a very safe, very fast, and we can use this in a non-destructive way, and also we can use in both qualitative and quantitative analysis. Now I can share some X-ray result of one of my work. Like here we can see the result of X-ray result of some slag sample from the early Bronze one, Sulampapua, Turkey. We can see the chart. There is this X-ray from the X-ray analysis. We found that this slag has iron, silicon, aluminum. Iron, the dark one, and then green one is silicon, and the blue one is silicon, and this green one is aluminum. So this iron, silicon, and aluminum is very significant because slag is mainly for silicate object and the ferric oxide, mix of ferric oxide. And also we can find some copper in a very almost 25%, below the 25%. So very few with a modest level. So this presence of copper, so we can also know that we in our sample there is a very low amount, below 1.5% sulfur. So this is how the XRF can show what type of element is present in our sample. I will back to the result, but if you see that XRF only can tell us what type of element is present in our sample, but we don't know this iron or silicon is in iron ferric oxide or in ferrous oxide. We don't know the actual phase. To know the actual phase or mineralogical phase, we can use XRD. The principle of XRD is very simple also, like the XRF. It's mainly X-ray diffraction based on the interference between the sample, crystalline sample, and the monochromatic X-ray. Usually in XRD, from an X-ray source, a monochromatic X-ray is generated, and this X-ray interferes with the sample, and then this sample makes some X-ray diffraction. And using Bragg's law, 2d sin theta equals to n lambda, we can count it, detect it, and process this diffraction. And we can have information about the mineralogical phase present in our sample. And one can ask, what is 2d sin theta and equal to n lambda? Here, 3d is the distance between the two crystal plane, and sin theta is the angle of the angle, and lambda is the wavelength of the energy. This XRD is very reliable for the identify the mineral phase, and also it can be used as a qualitative and quantitative analysis of which type of mineral phase is present, and also how much they are present. We can find out in this through this technique. Here is the example, the result of some XRD result of the same slag sample from the Sulampapua. In previous XRF, say that we in our sample we have iron, aluminum, silicon, as well we have little copper and sulfur, but we don't know iron is in iron, ferric oxide or ferrous oxide in mode. But this XRA, if you see the diffractogram, you see this red peak is a silica, and this green peak is phyllite. Phyllite is a mainly silicate mineral. So it's a silicate mineral based on iron, magnesium, and silicon oxide. So we can now know with this diffractogram that our silicon is in a quartz phase, our iron is in a phyllite phase. So this is how XRF result can be complemented by XRD. And this phyllite is very important because this phyllite is naturally not present in nature. It is only produced by the smelting activities. And now, but if you want to know what is the microstructure of our sample, then we must use another technique, scanning electron microscope or SAM technique. The principle of SAM technique is also very easy, like XRF and XRD. Is this technique, the principle of this technique based on mainly interaction between the electron beam and the sample. Normally, like if we see this chart, we will see that from the electron gun, a very narrow electron beam was produced, and then this electron beam was going through a cylinder panel, which was surrounded by some electromagnetic lens, and then it was heated by the bottom sample and produce some backscatter electron, and this backscatter makes some image two-dimensional. SAM is very effective for chemical elemental composition and for the microstructure, and most importantly, SAM can magnify object in order to 1 lakh times, and also can give a elemental composition out, like if XRF, for the XRF we know in our sample we have iron, silicon, aluminum, copper, sulfur. SAM will give how they were distributed. For example, I can show the same result of the same slag sample. Here we can see the SAM EDS result of the SAM EDS analysis. This is a backscatter image of a slag sample of the Sulampapua. Here you can see this is the lighter gray. You see the elongated lighter gray phase is the phyllite. This is phyllite, which was also detected by XRD. And also we can see this is a lighter white droplet. This is a copper. So now we know our droplet of copper is distributed in between the elongated phyllite crystal. So it is very important to know this droplet because this copper droplet only produced during the smelting activities. And also very important, SAM give an elemental map. Like here, we can know where this copper is distributed. This is the elemental map of copper. So we know copper is here, 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 here. And most importantly, we also know sulfur is where. If we overlapping this elemental map, we can easily see this sulfur and copper is associated in the same position. This means copper is associated to sulfur. It indicates that maybe this slag was, is a result of extracted from a sulfur-based ore. So we can predict in this way our XRF result, XRD and SAM complement each other, and we can know that in our slag sample is a copper-based slag, and it also have the phyllite, so it's the product of smelting activities, and also this slag can be generated from maybe related with a sulfur-based mineral. This tree technique has some limitation also, like XRF, the result is only cannot be fully quantified because it's a surface analysis, and XRD, sometimes XRD cannot identify minerals that are poorly crystallized. And SAM is have a poor sensitivity for trace element, which means that if any element have the lower atomic number than 11, we can detect through the SAM analysis. So it's better to use the multi-analytical technique rather than use one technique. Like here, we can easily, I can show that in my work that how XRF, XRD, and SAM result complement each other, and we can have a better picture. Now I will show some example from subcontinent. First India, and from my country Bangladesh. Here you can all of you can see some metallurgical examples that were found in subcontinent. In this subcontinent, especially India, is very rich in metallurgy. The metallurgy or use of metal is began from the 6000 BC. The site called Mehergor is a Prague-Harappan site. We found native copper, evidence of use of native copper, and then in the around 4500 BC, copper metallurgy or evidence of smelting is began. And in Harappan civilization, is the metallurgy knowledge of metallurgy is highly developed. You can see some example like here mirror, some weapons, some dancing bronze statuette, and also some bull statuette. All are found in Harappan site. So it easily shown that how this continent is reached from the 6000 BC to upward. Here here you can easily see some also some good example during the Gupta and post-Gupta period. Like this is a coin. This coin is made of gold, and this cast coin, this Pachmark coin is very marvelous example of casting technology, because you can see this is a symbol of Kumaragupta. He is standing, and his hand has a bow, and in the other side of the coin there is a Lakshmi Devi, and she has holding a lotus. So, and also there is a Buddha, standing Buddha from Sultanganj. It's a very important example of holocasting. And here's some iron pillar, which is situated in Qutub complex. It's also marvel because we easily know that iron is very resistant to the weather. It's a very, easily react to the weather, but this iron pillar is still now standing in as its own form. And also there is a dancing Naturaj, Denshi Shiva. So it's also an example of casting technology of Indian subcontinent. Now moving to Bangladesh, here's some example of Bangladesh context. In Bangladesh context, we found use of metals introduced in early history period, like Mostangar and Wari Boteshwar. From Mostangar, we found some mirror, bronze mirror, and also some features, some weapons. And from another early history site, from Wari Boteshwar, we found this bronze noble. This noble is very much related to the Buddhist religion, because some scholars want to explain this knob as a Mount Meru, and the surrounding is a Buddhist philology. And this is a Pachmark coin. The coinage system is the evidence of coinage system introduced in this area. And another type of artifact easily found in this area is copper plate, which is mainly is administrative order, evidence of administrative order. Here's some example from the Pala and contemporary period. Like here, this Buddha is found from Paharpur, Bihara from 19th to 10th century. It's a very important because if we see very clearly, there is a bulgar. It's the evidence of firing. Firing. Evidence of firing. You can see the bulgar because it's there is a firing activities occur in the Paharpur region, and this dated Borges Shotro found from the Bhojabihar Moinamoti is also 19th to 10th century. If you see, all the materials are 9th to 10th century. In this area, in Bangladesh context, 9th to 10th century metallurgy is developed in a very peak way. We can see some, this Bodhisattva is the largest sculpture, most probably it's the largest in South Asian context. And we also found some bell, large bell, where there is a Cauchan lion. You can see the Cauchan lion. This lion motif is very, very unique motif in a Chandra dynasty, which in the southeast region. It's so this all the material like this big size bell all indicate that there is a custom technology developed here, but we don't have any scientific study yet. And also the most important thing I have to share that there is no, in this Bangladesh context, there is no ore, no source of copper or tin ore. So maybe this material, this raw material of this product were collected from somewhere. Maybe it's a maritime, it's a product of maritime activities or maritime trade network. Here also some important things. You can see the gilding technology, example of gilding, but in our country, we only have 3 gilding sample. So we don't know whether this is a local product of local craftsmanship or it's coming through some trade or religious network. And in medieval, after Pala period, after the medieval period, we can easily find some canon. There's a huge, several example of canon that was used in using brass or bronze or iron. So we are coming to the end of my presentation. So what is the major challenges doing the archaeometallurgical research? In my experience in Bangladesh context, I found that most important 3 problems or 3 challenges doing archaeometallurgical research. One is lack of stratigraphy or contextual information. We have the metal artifact stored in museum or private collection, but we don't have the stratigraphy or contextual information. So when we want to seek an archaeological answer, it's very problematic because doing archaeological research, you have to have a stratigraphic or contextual information. And second important challenge is most of the bureaucratic seems metal object as a precious object. So the authorities or institution are not willing to give for scientific study. So you will be face very bureaucratic problem to have the sample for your scientific analysis. And also in this reason, like me, I just completed a thesis in archaeometallurgy now, but here there is not much specialized knowledge because when doing ancient metal artifact, you have to know some specialized knowledge and also some laboratory because the XRF, maybe some lab has XRF, but they are doing analysis current metal and analysis past metal is very different because past metal going through some aging process. There are some contamination. So we have to a specialist laboratory as well as specialist knowledge. But here in this region, it's just developing. But still, we have a prospect. Like I think there is a huge prospect in this particular discipline. Like we can make a regional collaboration to stress out the past metal technology in a large context. Like what is the history of using metal in this area? When copper was used, when copper alloy like bronze and brass was used, how the raw material is collected. So a large history can be, explore in a regional context, and also this knowledge can be utilized for a conservation of metal heritage. And also through the, like I share that in my country there is a large, in a certain period, large casting technology developed, but we don't have any source of raw materials. Somehow it's come from outside. So there must be a metal trade route, and we can explore this trade route and maritime network. And also doing archaeometallurgy, we can revive and exchange the traditional metallurgical knowledge and boost up the regional economy, tourism, and our past past knowledge as well. So thanks. This is I'm now the conclusion of my presentation. Thank you very much. If you have any question, recommendation, or suggestion, you can ask me. And if you have further query after this webinar, you can also contact me, sabikon_shethi@junipedu.com through my official email.
Okay, thank you very much for Ms. Sabikon for the great presentation. Well, before we go on, as information again, if you have any questions, just type on the chat box. And then regarding to the attendance list, it's invalid, so we will share the new one at the end of the presentation. Thank you. And again, please for the all participants to mute your mic. Hello, Mr. Harry.
Yeah.
Yes, please, time is yours.
Okay, thank you. Sorry, I cannot start the screen share. Please open the share screen.
Yeah. Yes, Ms. Sabikon, please close your share screen.
Oh.
Just a minute.
Still open. Sorry.
Okay.
Okay.
Please, Mr. Harry.
Okay, this one. Good afternoon, everybody. My name is Hari. I'm from the National Research Center of Archaeology in Jakarta, Indonesia. First, I would thank you to Ms. Sabikon Naher, very good presentation about Bangladesh in India. And for this international webinar, I would like to thank you for the Hasanuddin University and the IAAI also. So in this my presentation, I only sharing my experience working in the Archaeometallurgy in Indonesia. So in the couple years, I working Archaeometallurgy in Indonesia. This is my presentation about the introduction of the Archaeometallurgy in Indonesia is from the prehistory to Hindu-Buddha. So my outline is the introduction, rise and development of archaeometallurgical research in Indonesia, some sample of the metallurgy from the prehistory to Hindu-Buddhism, my research sample, and the challenge and scope of the archaeometallical research in Indonesia. So this is the Indonesia is the insular of the Southeast Asia. If you see the comparison between Indonesia and Europe and China is a very large area. Yeah, it's with we have many sea actually. It's more than a land. So it's we have the more than 70,000 islands with the ethnic and language. From this territory, we have so many culture, yeah, from the prehistoric period to the Hindu Buddhism and Islamic colonial, and after that the independence era. So from that is a result so many actually artifact from the prehistory to the colonial So for the metals is begin from the prehistory. I think is from the Paleometallic to the colonial period. So we make so many landscape, or sorry, I think it's so many chronology. So I want to talk about the history of the archaeometallurgy research in Indonesia. Actually is from the colonial, for the outsiders, from the Rumpius. His report about the bronze drum in the Selayar in the 1917, is the 18th century. So there is also from the colonial people from the Dutch. But the first one is from the Van Heckeren book, is the Bronze Iron Age in Indonesia. But this book is not from the Heckeren research only. He is only doing the research about the metals in the museum in the Jakarta. So it's not from the field actually. So there is also from the dissertation of the Wolfgang Marschall, is about the metallurgy in Indonesia. So in the 2000s, there is a undergraduate student who's doing the archaeometallurgy research in Indonesia, is from the Indonesian University, but now is no more decreased about the student who doing the archaeometallurgy research. In the 2000, there is Mr. David Bulbeck doing the OXIS, the Origin of Complex Society in Sulawesi, doing the research about the irons in Indonesia. So actually, we have the first archaeometallurgy, and archaeometallurgist in Indonesia is Prof. Timbul Haryono, is from the Gajah Mada University. Now he is retired, already retired. Is with the professor of Nata Pintu in Thailand, also is college. And for the Indonesia, there is Miss Anggraini Priyadi and Miss Sudarti also doing the metal research. For the European people and not the Indonesian is doing the archaeological research in Indonesia. There is an Ambra Kalu doing research, many research in Bali. Miss Holdo also is she's a Korean doing the OXIS, following the OXIS research with Mr. David Bulbeck. Also, Mr. Thomas Oliver Price is doing the research in the Bali also. The Indonesian, there is Eri Sudewo, me, and Mr. Patrick. So it's mostly is the archaeometallurgy in Indonesia is belong to the social science, but now we try to make it a little bit hard science. We're doing the analysis more in the laboratorium. So this is some example of the metallurgy product in Indonesia. If you see from the metallurgy product in Indonesia is mostly is influenced by Dongson. So it's Dongson in the Vietnam, but in the mainland the bronze is around 1100 BC. So it's and the iron is around the 500 BC. So in Indonesia is from the dating that we have the dating around the 385 yeah, around that. Sorry. So I should add this one. So it's not very far actually from the mainland, so East Asia. for the bronze and iron is rise in the Indonesia is quite later, yeah, because probably is not directly from the sea, yeah, but is from the land. So if you see in here, the bronze and irons is together. They came from the mainland to the Indonesia. You see in here, there is this is in Kerinci in the Sumatra. Is a very quite same the motif and the urns with the mainland in the actually in the Cambodia. So this is from the Harimau Cave. Oh, sorry. This is from the Harimau Cave in the Sumatra also. This is so this is from the Rote, and this is from the Selayar also in the Sulawesi. So this one is the new discovery from the local people. Actually, this is kettle drums is buried under the lake. So the fisherman is catch it with the net and get this kettle drum. So the interesting about the prehistory in Indonesia, but with came from the Pangkung Paru in Bali. So many researcher, European researcher, doing research in Pangkung Paru in Bali. So there is an Sambiran also in Pangkung Paru, because from this one is very similar with the Archaeometallic motif in the mainland Southeast Asia. But from the others, not only from metal, there is a beads also is evidence is from the Roman. So actually there is a connection between the Indonesia and the Central of Asia also. Yeah. So this is the connection is though actually Indonesia with the insular is not very remote area, but it's during the 2000 years ago is already very what is this is many people, yeah, it's like so many people come or exchange. So this is from the prehistory. So we have the proto-history in here. So actually is came from the east is the east East Sumatra, in the South Sumatra. So if you here see this is not the tourists, but it's a looters. It's a looter. So came from the precious metals like a gold. They find the gold in here. So this is very sad actually, but we don't have any much power to stop them. But from this evidence there is a gold, iron, and also bronze in here. If you see this is the radar of the ship here. So from the Hindu Buddha period, actually is the I mean the rise. Sorry, I think is the peak of the metals, yeah, metals period. So if you see in here in the down, there is a relief in Borobudur, show the merchant shop in Borobudur. So the people is in the buy and try to buying the gold or metals in here. So there is a shop in during the 8th century. Yeah? So also in here there is a funeral mass made from gold. So this one also is from the Wonoboyo gold treasure in the central Java. So during 1990s, there is local people digging the soil and found this treasure. I think is from gold for 18 carats. Yeah, the gold is 18 karat is the very precious metals. So it's during the Hindu Buddhist period. So the metals object become precious or the social status for the owner. This one is the Majusri statue is weight is the 10 kilo with the pure gold. Pure silver. Yeah, pure silver. It's the Majusri. This one is the Buddha Sempaga. This is the Buddha Sempaga or Dipangkara were found in the Sulawesi, which is still we still don't know about the from where this one is. Probably is the from the ship. I think is from the ship. Because it's not found in the site. This one is the Chris dagger handle from the gold also. So this is the Avalokitesvara from Jambi, made from the bronze covered by gold. So this one is the hanging lamp. Yeah. And the good one is that from the Belitung rack there is a gold from the Belitung rack with the very good motif in here. So it's from my research example. Yeah, I made is from the Gua Harimau cave. Is from the prehistoric period. So from the Gua Harimau cave is analysis with the metallography. So there is casting and working for this one. So if you see for the casting there is a dendritic, yeah, dendrite in here. So it's the typical of the casting technique. And then you see this here there is a twin boundaries or the annealing, yeah, for the working technique for that. So there is a two technique is made for this metal. Yeah. So this is for the SRF analysis. You see here the metal is made from the copper and tin, but one metal is there is an additive with the lead. Yeah. So why this metal is made of from the from the lead? Because with the motif probably there is during the solidification is more. There is more fluid to enter the motif, so it's the additive for the metals, yeah, for the lead. So this is for the morphostylistic analysis for the metals object in the Harimau cave. Is mostly probably from have the same feature with the mainland in the Myanmar. So this is for the Montalat, is the Indonesian ancient furnace. Is the research of the three years research in the center in the Borneo. So we tracking from the Swenner book from the 1853 with doing the expedition for the Barito River. he saw the local people try to make the goods from the metals. So actually we don't have any clue at the first time, because it's the totally lost at what the Swener saw. So we should we doing the survey, and we found the furnace. This is the first furnace look like after we clean the grass. Yeah, this is the furnace look like, and near the furnace we found so many slabs, and near the furnace and the side we found so many laterite, laterite, and not far away also we found the coal, but the fuel for to cooking the laterite is not from the coal. So our evidence is probably coal is introduced by the Dutch during the colonial period. So the local people still don't know is the coal is what for, because this is the coal is very near with the site. It's only 10 meters, only 10 or 15 meters from the site. But they didn't use the coal as the fuel. So this is the site. You see, this is the furnace. This is the iron ore. This iron ore already crushing and ready for to the cooking. Yeah. So after we found the furnace, we tried to make the what is the experiment for that. So we made the furnace to make the experiment how the ancient people actually try to separate the iron. So with this, we crush the laterite and the hematite, and after that we count it and we cook it around the 10 hours. So the result with the thermocouple is show the temperature is quite high, yeah, very high. It's around 1,750 or more probably. This is shown the error because its the temperature is very high. So this is the furnace. With this one, we success to separate the iron ore with the ingot, yeah, in here. So we quite successful in with this experiment. So this is the challenge and scope for the archaeometallurgy in Indonesia. Only very few researchers interested with the archaeometallurgy, but with doing the archaeometallurgy, you need the device and the lab actually, because you cannot only see the surface only. So sometimes for the metals object is already in the museum. So with the conservator, sometimes we cannot do the destructive analysis because it's not allowed. So mostly in Indonesia, only the descriptive analysis for the material, for the metals object. Is they didn't try to touch more deep doing the analysis. So it's still more work for the Indonesian archaeometallurgists to doing research in Indonesia. We still much more the collaboration with the scholar in the Southeast Asia and Asia, and probably from the Europe also, who interest with the archaeometallurgy in Indonesia. So many questions actually for the archaeometallurgy in Indonesia, because from the old perspective, we always thinking about the metals object in Indonesia is always from the Dongson, but the latest research from the Melissa Cadet and the Oliver Price has shown the Dongson style is Dongson is not always from the Dongson, because from the from the Sembiran, Pacum, and the others is in Bali show actually the resource is not from the resource is show from the Laos in the Filaburi complex site. So this is very interesting, I think. So until now we don't know the furnace in Indonesia, because we only found the furnace from the very late, say, I think is 18th or 19th century for the irons, but we don't know the old furnace in Indonesia look like. So for the also for the resource for the mining is the we still don't know. There is a mining site in Indonesia. For the ancient mining site, we still don't know. Is the local or import, or the local people, or the introduced by the outsider? We still don't know. We still have many work to do in Indonesia to recreate the chronology about the metals in Indonesia. I think only that. Thank you so much.
Okay, Mr. Harry, thank you very much for your presentations. It's very great and interesting that how both of you combine a research with a social and a scientific approach. It's so amazing. Well, we'll go ahead and take some time for questions. And I will choose some questions from the chat box. And I will read all of the question first, and then both of you can answer it. The first question from Miss Mentari Charisma. Yes, this can be the question as well for Mr. Harry. When is metal found in Indonesia and India? At the time of the discovery of metal for the first time, how to find out the best and worst quality of the metal and the strength of the metal? Ms. Abukun, can you hear me?
Yes. So I will answer now, or I will answer after all the question is.
I will read all the question first. Okay. The second question for Ms. Abukun again, from Fu to Tieng. How effective is XRF or XRD in identifying the potential source region for metal artifacts, like for pottery? Due to the mixing of clay sources, sometimes this approach may not be very effective. Can you get it, Ms. Abukun?
Yes.
Okay, and now we move to the Mr. Harry. From Miss Siti Khoirafia, is there any metallurgy research on the authenticity of the original Japanese work or culture material without mixed Hindu-Buddhist culture or the Indian community? Is Borobudur without any touch of other cultures? Because there is an opinion that the Japanese are not Proto-Melayu, but Deutero-Melayu. And then we have, again, for the Mr. Harry, where does our Indonesian ancestor get the knowledge to use plates or glasses from bronze or gold or metal? Is it the same with glass or spoon from stainless steel we use today? Why do people today even use plastic for glasses? So these are the questions we choose. And you have already for the speaker to answer. Okay, Mr. Bikun? Okay, yes, please.
For me, there is two questions, right?
Yes.
Yes. So first one, if I not wrong, want to know when metal was first introduced in Indonesia and India, right?
Yes.
Yes. I think for Indonesia, Mr. Harry can answer very right way, but for India, I can already say that we have found the evidence of metallurgy from Mehergarh, a site, a early pre-Harappan site called Mehergarh is situated in Balochistan and around 6000 BC. But we have found only beads, a metal beads from a cemetery. But there is no evidence of smelting. Maybe it's a use of native metal. But the evidence of smelting is later. It's from the around 4500 BC. And then 2500 BC towards the Indian subcontinent, metallurgy developed in a larger scale. In Harappan civilization, we found some statuette as evidence of casting. So from the 6000 BC, there is evidence of use of metal, but actual metallurgy, when started the smelting, is around 400 and 500 BC. And the second question was for me that how effective, right? How effective was XRF and XRD? If I not forget, the second question was for me was how is the
effective?
Okay. How effective XRD in identifying the potential source? Okay, it's a very important question because we really know from where we collect our raw material. Like I show some metal statue in my country, but we don't have any source, metal source. So somehow they are collected from outside. So how can we trace which sources are used for this, collect this raw material? I think XRF and XRD is not very much effective for finding the source. If you really want to correct it, know the source, you have to use another technique like ICP-MS. It's an inductive coupled plasma mass spectrometry, or you have to analyze lead isotope, because you have to compare the trace element from your sample and also the possible source or sources. But XRF and XRD is not very much sensitive to the trace element analysis. We can do by XRF and XRD, but not the accurately trace element analysis. So it's not very much effective. We can have a preliminary idea, but to pinpoint the source material, to know the source, we have to use another technique. So I think that was the answer from my side.
Okay, thank you, Ms. Hadigan. I think it's clear enough. And now we move to Mr. Harry to answer the question, please.
Okay, the question is when actually the metals is entered in Indonesia, yeah? So actually it's still a debate until now, when actually the metals enter the Indonesia. But we believe metals in Indonesia not more older than mainland Southeast Asia. So probably is because the mainland Southeast Asia is the metals is like I said before is enter around 1100 BC for the bronze and 500 BC for the irons, and the metals enter the Indonesia is quite later than. The oldest and more provide dating we have is from the Harimau cave is around 385 BC. So it's not very far actually with the site in Penang, yeah, in the Kedah. So it's around the 500 BC for the iron. So it's the around the 500 BC for iron is rise in the Southeast Asia, I think. Yeah, around that.
Okay, thank you, Mr. Harry. Because we have some questions already in the chat box, and we have a limited time. And maybe the participant who want to ask directly to the speaker, just raise your virtual hand, and we will unmute your voice. So if anyone wants to ask directly to the speaker, just raise your virtual hand. Okay. Okay. Okay, nobody? Oh, yes, okay. There's some, and we choose Dr. Rafi S. Gupta. Can you hear me? Hello, Dr. Rafi. Hello. Could you please also to show us the video? Dr. Rafi? Okay. Can you hear me, Dr. Rafi? Yes, please. I'm not sorry, I can't hear your voice. I'm so sorry. We cannot hear your voice. Yes, yes. Dr. Rafi, yes, please. But we cannot hear your voice. Okay, maybe we will choose another participants because we can hear your voice, Dr. Rafi. Yes, please, if you, again, other participant, maybe you want to ask directly to the speaker. Okay, nobody? Well, okay, I'm so sorry, Dr. Rafi, we cannot hear your voice. Because we have a limited time, we still have one question for both of the speakers. I think this is a good question from Mentari Karisma again. What are the most difficult challenges when researching metals? And this is for both the speakers. Ms. Sabikun and Mr. Harry.
Yeah. Who first?
Yes, you can first. Yes, please.
Okay, the most challenging doing the research in archaeometallurgy is when you do the survey, because when you do the survey about archaeometallurgy, metals, object, people recognize you as you know, as the geologist who want to search the mining site or mining. So people still thinking about the metals object is the very precious. So they ask you many uh, many what is for bargain for that. Yeah. So I think it's the most challenging is the when you do the survey.
Okay, let's
Okay,
see
so
what Mr. Vigon will say. Is the same answer, or please,
I
Mr.
think
Vigon?
it's almost same, but I found the mindset of, you know, the institution or the private collection who have the metal sample, their mindset of is very much typical. Like they are not open because of some, maybe they are afraid of you know, destructive, because when you want to know the technology, you have to start some sort of sample. It be register your specimen or the art object or the artifact. So people they are not very open to give you the permission, or not, they are not very much, you know, open-minded for the
Okay.
scientific. So this is the
Yeah.
same.
Yeah, I think it's close, similar. Yes, I think you already answered the question, but yes, you know that we have a lot of questions in the chat box, but we have a limited time. So maybe you can contact directly to the host or to the speaker. I think it's a good idea. And then now, before I close the webinar, we have already shared the new attendance list. So don't forget to fill it out to get the e-certificate. And I think it's good for now. Thank you very much for all the participants. And it was a pleasure being with you today. And before I close, I would like to conclude our webinar. So archaeometallurgy is closely related to archaeology, which uses scientific approaches that provide insight into the technique used to produce different metals. Because the scientific techniques can provide information about the manufacture and consumption of range of metal that can be explained with some perspective with different settings, like in India, Bangladesh, Indonesia, where was the metals found. So I think that's all. Thank you very much again for the participants. Thank you very much for the speakers, Mr. Sabikul Naher and Mr. Heri Octavianus Sofyan, who have provided a great and insight to the audience on archaeometallurgical research topic. And now we can see how the some perspective of this topic and the different settings. And also thank you very much for the host for the Association of Indonesian Archaeology, Sulampapua, and the Department of Archaeology, Faculty of Cultural Science, Hasanuddin University, Indonesia. I think that's all. Thank you and see you next time. I give it back to the host.
Okay, thank you so much, moderator. So thanks so much for all the participants and speaker, and still have some questions. So we will try to keep in touch with the speakers and to try to answer the question, and we will send it to your email. And don't forget to fill it the list of attendance today in order to get the certificate. Yeah, so it's the last time for our webinar today. So before we close, we would like to take a picture together. So please make activate your video, please. Okay, thank you so much. So this is the last time. If anybody want to talk, please, we still have time to talk each other, but we will manage everything. Yeah. And we say thank you very much for our participants. We are from the Association of Indonesian Archaeologists and also from the Archaeo Department, Hasanuddin University, and some support from Ministry of Education, Indonesia. Yes. Now you can leave our meeting today.